Am I audible? Yes. Hi, good afternoon, everyone, and welcome. We are incredibly excited to be hosting our first ever webinar here at SwitchOn, and we're truly grateful to each one of you for joining us today. So, to introduce myself, I'm Rajeshwari Yadagi, People and Culture Specialist at SwitchOn. Over the years, I've had the opportunity to work across a range of industries, but stepping into the manufacturing space has been a truly exciting and eye opening experience. Now, to talk about the force behind this event, Switch On. So, we believe that the future of manufacturing is intelligent, precise, and automated. Here at Switch On, we are pioneers in AI powered computer vision, revolutionizing how factories achieve zero defect manufacturing. So, our cutting edge solutions help industries move beyond manual inspection and unlock next level quality and efficiency in real time on the production floor. So today's webinar is about exploring how SwitchOn's AI-powered DeepInspect system is transforming quality inspection in the glass bottle manufacturing industry. So you'll be able to discover how industry leaders are leveraging this advanced visual inspection platform to enhance defect detection, reducing manual errors, and also ensuring consistent product quality at scale. So without further ado, let me introduce our panel. We have Neil Lacerado. We are excited to welcome Neil, who leads product at SwitchOn. With over a decade of experience solving complex business problems, Neil brings a deep understanding of how technology can drive impact on the ground. In today's session, he'll be sharing insights on how AI is transforming quality control in the glass bottle industry. And next, we have Shishir Pali, Sales and Solutioning Manager APAC, having more than 8+ years of experience in the design solution of complex industrial use cases for clients like Diageo, Unilever, Harlan Glasses, P&G, ITC, and more. So Shishir will be taking us through the problems of the glass bottle industries related to quality of product. So let's welcome our panel, and Shishir is taking over.
Sure. Uh, Hello all. Thank you, Ragi, for introducing us, and thank you everyone for joining from wherever you are joining. I'm pretty sure that it's already been a hectic day, especially since all of us are belonging to manufacturing industry. So I would not waste any further of your time, and let's take a deep dive in today's session. This is actually first of uh, our webinars, which we have specially curated on glass bottle inspection. And then as we unfold in further slides, what is going to be, we are promising that there are going to be many more of such sessions which we'll be having and which we will be bringing for the manufacturing industry. So with that, I think the stage has already set by Ragi. So I think just for a brief introduction, I think for some of the people who don't know what SwitchOn is, at SwitchOn we are actually a 7-year-old company who is working in the domain of automating the quality inspection, and we have been helping various clients such as Diageo, Head Glasses, specifically in the glass industry, and then P&G, Unilever, IDC, in CPG, and then in automotive there is like whole gamut of people or clients with whom we are working and whom we are helping to cut down their manufacturing cost, especially in terms of the quality aspect. So let's take a deeper look in the problem in hand, and then we'll actually open the questioning session at the end of this discussion. So I'll just ask you people, if you have any questions, you can just put that question over the chat, and then we will take it back once we are done with the session. So yeah. So as we all know, like in today's world, since manufacturing is getting very complex, as the modern supply chain, especially in CPG, it's too much of complexities are involved, given the customer is having so many of choices, and the competition has been stepped up a lot, especially in the markets like India, where the cost is a major concern. So often we see that on a single line there are like multiple SKUs which are running, which imparts like various mechanical complexities, due to which there is some complications, which leads to some a few defective or few errors in quality aspect of the product. The second most point, also, which is there, is the fluctuating demand between the sales and the marketing or the brand changes which we have, which again imparts to the SKU variations and the production variations, so that the volume in which the product has been manufactured, that is also getting changed at a very rapid pace, so that there is very less time for even the production team to ensure that the things which are required are already taken or are already been taken place, and also for the quality team to train the manpower which is there, in order to ensure the proper quality of the product is being met. And third most important point which I would like to emphasize is on the volume and the speed at which the production is happening. I've seen some of the lines at few of our customers are running at close to 400 bottles per minute, which is actually making it quite impossible for any human-based inspection system which has been deployed to do this inspection and checks, which uh, actually creates a environment where the defect, I mean, even if we go with a random sampling, there is always a possibility that the defects has been missed out in certain lots, and the entire production of the batch or the day or maybe the week will be put on a hold, which again imparts to a very big cost. So all of this, if we combine, there is inherent very big latent cost to manufacturing in terms of the quality. And this is why we are focusing, and even the industry in these days are focusing majorly on the quality aspect, as the brand value is also something which customer is relating with the quality. So with that, I would actually take it in furthermore discussion specifically on the empty bottle inspection, which is our today's topic for the discussion. And as I think all the folks who are joining in here are quite experienced in glass bottle manufacturing, so I'll just quickly explain what are the different type of defects and what are the different terminologies which are there in the glass bottle, so that it's clear to everyone. As we know, for any bottle or any product, there are like different areas in which the product uh, quality has to be checked and ensured. Specifically in glass bottle, if we see the top of the bottle, which is the crown, it plays a very important role, because every time that is the first point of contact between the consumer, if he is consuming the bottle directly from the if he is consuming the product directly from the bottle, then this is the point where the defect, any minor defect or a major defect, can play a pivotal part in the journey of a consumer. So this is where the checks are being done, which is the bore. And even in the bore, I think, which majorly the filling lines have to fill the bottles by inserting the needle inside the bore. If the dimension of the bore are not properly aligned, then this will also impact a damage into the filling line, which again cross relates to the defect or the time required to fine tune the systems or spend in maintenance, and then again it overall affect impact the cost in manufacturing. So moving forward, there are like again different type of defects which are there at the bottom of the glass as well, which happen majorly because if there are like returnable bottles in some of the cases, which are market return bottle, there might be some mud or dust which settle down at the bottom of the bottle, and if it's not cleaned properly, it will still stay there. So or it might happen in during the knurling process, as bottle are being transferred from one conveyor to another at a very high momentum and speed. Due to the transfer of momentum, the defects might be getting imparted on the knurling area. So all of these are actually very difficult area, even if we see from a vision, from a human point of view, to do inspection at a whole batch or a whole production level basis. And even the other complexity is the speed, which makes it quite more impossible to do this type of checks. So in Ragi, can you? Yeah, so I mean, so the earlier methods which were used traditionally in the industries were actually, so there were I mean, it's not that machine vision is something which is new to the industry. It's already been there. It's been close to 30 years that these soil out systems have been deployed at various plants. But the major concerns or the problems which I have actually seen while visiting some of the plant is that majorly these systems are rule based, so which means that there needs to be high level of understanding within the operator to in this system and to use this system, and then he will have to actually put some rule based guides set up, and you can understand with the variation of SKU which is coming in, and the production changes, and also the marketing brand changes which is requiring for every customer. This makes really complex for the operator to keep twinning the system time and time again, and it takes a very long time, first of all, to train this type of system. And the second more important point is that these systems are very much dependent upon uh, good and both bad set of data. So there is a very large set of data which are required to train these types of system, which again is a very big complexity from a from a manufacturing point of view, because in manufacturing we never have control on what type of defect might come in. Just a case in point, last time I was just visiting one of our customers. So they just brought in, I think they just started producing a new type of bottles. And because there is a minor change in their process, a new type of defect has started to take place. Now when I see our system performing in comparison to that, and then definitely Neil will take us in more broader detailed discussion why our system and what are the differentiators in ours and the traditional system. But I have seen that the traditional vision system has failed there, because there was no prior history of this type of defect. And because of which again there is a very high deployment time. And if again, if there are like very minor variations in the product, in the product finish, and again in manufacturing, as I was saying, there is no control. There might be a ideal part which is produced for a shift, but it cannot be continued throughout the month or throughout continuous shifts, because the operator will change. There will be certain changes in process. There might be certain wear and tear in the manufacturing setup as well. So all of this will impart little bit of variation in the product, and these traditional vision systems are not able to take care of this variation, and because of which it results into very high false positive rate, and resulting into keeping this system offline, not in use, bypassed, and all the investment which has been done by manufacturing setup, which is close to in crores, is just been sitting idle, or is just been gone to waste, is what I've seen. And more, and I think one of the biggest differentiator that we are going to bring in here is that there is no way to have a defect classification or analytics so that the root causing can be done. So these are the major problems which I have seen with the traditional vision system. Can we move to the next slide? So yeah, and this is the point in case where I was talking about. So as you can see, the image on the extreme right, or actually the third image, there is a very minor defect which is at the crown of the bottle, and it's actually just a scratch. But since it is at the crown, it is very more like it is the most important defect from a consumer aspect, because the consumer for consumer this is the first point of contact whenever he is going to buy this product and going to use it. And this is where actually the traditional machine vision system fails, as there is no big contrast or no big pixel difference between the two, between the good part and the bad part. Similarly, on the left side you can see another example where there is a variation in the circumference of the crown, which is again a very minor defect, even from a human eye. And usually, since if we if a human eye is exposed to several defects over a period of time, it actually makes a muscle memory to kind of ignore this type of defect. And this is where actually, uh, where this is the place where switch on is actually bringing in the difference. And I would actually now hand over this session to Neil so that he can take us in much more depth about how switch on system works and take it forward.
Hey folks, I think I'm audible. Okay, awesome. First of all, thank you so much for taking out your time on a busy Thursday afternoon to attend the session. I'll be covering three things today. I'll be talking about how traditional vision system works, right? I'll also introduce you to how an AI-based vision system actually works, and I will also talk about some indigenously developed technology by us here in Bengaluru that can actually help solve some real-world problems, right? So, first, let's talk about how rule-based machine vision system works, right? These are your traditional machine vision systems, which are mostly available in the market. Now, to understand how this works, we need to understand what is an image, right? So all vision systems use a camera to capture an image of a product, right? This is an industrial camera that most systems use. Now, these images, when you zoom into these images, right, when you magnify them, at the very basic component, what you see is there's something called pixels. Now, an pixel is a individual color. So every image, when you zoom it into it, each pixel represents a color. When all these pixels come together, multiple colors come together, they form an image, right? Now, what the traditional rule-based systems do is they zoom into that image, they take the value of color of each of these pixels. So if you look at the presentation, you can see that all those squares, they're individual pixels, they're individual color points, right? And there is a reference image, which is your master image, main image, which is of a good product that you traditionally set. And then you have the product that the system is inspecting. It takes two images and then it matches the pixel in each one of these images, right? And it creates something called a result image, which is wherever there's a difference in color, it highlights that region, right? Now, what the algorithms usually do, and again, I'm simplifying this for this webinar, but things are a little more complex than this. But at a very basic level, at a very simple level, what these systems do is they count the number of pixels that are different, and basically set some kind of a thresholding, which says that if there are more than this many pixels that are different, then that product definitely has something that is different, which means it's a defective product, right? Now this works, right? But there's one big problem with this whole method, which is um, images change over time, right? Your products change over time. So maybe there's a slight label shift. Maybe the position of the bottle is a little different. Maybe the defect comes in different positions, right? And sometimes it looks very identical. So in a lot of cases, traditional vision systems start failing. That is why we started developing an AI-based vision system. We'll talk about how an AI system actually works. Right? It works like how you and me look at objects and recognize them. For example, you see an image of a bike. When you look at a bike, you don't imagine what's the color of the bike at each point, right? What you see is you see a wheel, you see a red color panel, you see the headlights, right? You see the brakes, etc., etc. You see different components. These components are called features. So what we do in an AI-based system is we take the input image, which is the raw image, we run it through a neural network, right? This neural network has an algorithm that is developed by us here at SwitchOn. This algorithm extracts different features in that image. So in case of the bike, we have shown what are the different features that will extract. It learns and remembers these features, and then it comes out with an output. Now, once using this method, we use multiple images and we train these models. And this is how a bike looks. Once it learns that, right, when you give it an inference image, which is of a real world bike, it will automatically match these features. If the features are identical, it will say that this is a, yes, this is a bike, this is what I learned it is. Or else, no, this is not a bike, this is something different, right? So that's how AI powered vision systems work. Now there's what is the difference in approach, right? So in a AI-powered vision system, you do not have a concept of tools. You basically teach these algorithms using images. So you capture reference images, you capture as many as 200, 300 reference images. You just say if the image is a good or a bad, right? It's you just say that this is a defective image or this is a good image. Now, once you do that in the software automatically picks up these images. It sends it to an AI model, which learns what is good, what is bad, and then you can use that model to do inference. In a conventional system, what happens on the other hand is you only have one reference image, and on that reference image, now you need to put a bunch of tools. Is the color different? Is the position different? What is the dimension between 2 points, etc., etc. Now, to do this, you require a very skilled operator, right? And in the real world, what happens is whenever there is any kind of variation in your part, there will be a false prediction, which means the conventional system is not able to identify that this is the same part. It thinks of it as a defect because it's looking at a very microscopic level. It's looking at individual pixels and making a decision, right? Versus an AI system does not look at an image at a microscopic level. It's looking at different features, and if the features are same, it will still say that the image is good or bad. We'll get into more clarity as we go forward. Now, I'll talk a little bit about switch-on systems versus other rule-based systems, right? So what we do at switch-on is we take all these good images. We can do a model. We do a model training, which is we create this AI model. Usually, it's about 200 good images that we require, and this training can be done end-to-end within 45 minutes. Again, the number of good images might vary based on what kind of defects are you really trying to capture, what is the variation of your part, etc., etc. We can also run multiple models. Why this is useful, I'll actually cover this in the next slide. So in traditional systems, you have to put multiple tools on one image. Over here, you can use multiple images to create one model, and then you can make multiple such models for different use cases and run them together, right? AI-based systems obviously can work at high speed. We have implemented at about 600 parts per minute, 700 parts per minute. We can do that, and we can set up demos within a single day. So it's very straightforward. Implement a system like this. Now, while working with AI-based systems, you will hear these two terms, right? Supervised versus unsupervised. So what are these terms? These are different ways a model can be trained, right? So we'll talk about the supervised approach first, right? So in a supervised approach, what happens is you take a bunch of defects, right? And you train the model to identify these defects, which means you take 100 images of bottles which has scratches on it, and you train the model to learn that, hey, this is a scratch. So whenever this scratch comes in production, you identify this and you detect it as an NG, right? In an unsupervised model, what happens is we collect a bunch of good images. We train the model with good images, saying that this is how my good image should look. Anything that does not look like good is something that is a defect. Now, what is the benefits of each of these models, right? So I'll talk about unsupervised first. In unsupervised models, what usually happens is because you're only training the AI model with good data sets, it learns to identify your good products. So any kind of random defect that comes during production will be detected as an NG because your model knows what a good product looks like. And if there is any kind of deviation in a good product, that's a bad product. In a supervised approach, because you're training your model with defects, in case you miss certain kinds of defects, maybe a crack came on a bottle which looked very different and you didn't have that data set before. So your model has not learned that kind of a crack. Maybe there is a chip off at a very different angle which was not trained before. Your model has never seen something like that before. So because it is not able to detect, it was not trained on that kind of a defect, it's not able to detect and it might miss those kind of defects, right? Here at SwitchOn, we do surface detect. We primarily use unsupervised models to do detections. However, we do have the ability to use supervised models as well. But as I told you in the previous slide, because you can run multiple models, SwitchOn, what we also support you is running an unsupervised model and then piping the output of that model into a supervised model. So you can first run an unsupervised model to identify that there's a defect. And once you know that there is a defect in a particular bottle, you can run that data through a supervised model to identify what type of defect is it. Is it a scratch or is it a dent or is it a chip off, etc., etc. So SwitchOn also has that capability. Okay, so I will focus a little bit more about how unsupervised models actually work. I actually covered this in my last slide. So what are the benefits, right? So you don't need to label every defect as a scratch, as a crack. You can just say whether a image is good or is it a bad. If it has a defect or it does not have a defect. As long as you do a simple labeling of good or bad, you can train an unsupervised model. In the supervised model, you'll have to actually define where the defect is and what is that defect. So you'll have to mark the area which has a crack and you'll have to say that this is a crack, right? So you don't have to do that manual labor, which means deploying an unsupervised model is very, very, very quicker compared to a supervised model. In case there's a new kind of a defect, right? Something that the model has not seen before, it will still get defected as NG. That is another benefit. And you do not require, since you don't need, images don't need to be labeled, you can just do good or bad. The production downtime is very minimal for doing a model training. So now let's talk a little bit about performance and how that compares, right? So these are some performance metrics that we have benchmarked across multiple deployments that we have done and SwitchOn, and this is what we are able to achieve. Now, the highlight here, which separates this system from other systems, is the true negative rate, right? Which is at 100%, which means using SwitchOn systems that deploys unsupervised models, there is no chance of a bad product getting packed because the models are trained on only good products, right? So in case there's any kind of a defect, you will never have a true negative. It will get detected as NG. This is something that can be achieved using a unsupervised AI model. This cannot be achieved using a supervised model or any other kind of approach because you're training the data set on a good image, on a bad image, right? Okay. This is a simple architecture. So at SwitchOn, we are primarily a software company. So we are not, we excel in making software, which is our AI models. We use off-the-shelf hardware, which means you have the flexibility to choose any manufacturer of your choice. So for cameras, we support all GenICam compliant cameras. This include industry-leading cameras like Basler, Allied Vision, Omron, Bomber, etc., etc. We support over 50 plus cameras. You can choose which camera you want to use. We do have a preferred camera that we choose based on the image quality, but the choice is yours. In the production line with the PLC, we also support multiple PLCs like Siemens, Mitsubishi, Omron, and Delta. We use the Modbus TCP/IP protocol, so any PLC that supports the Modbus TCP/IP protocol can be used. The computes that we use is also standard off-the-shelf computes. So you also have flexibility, you have total flexibility in the hardware. I'll also run you through what kind of capabilities we have with our software DeepInspect. So we can do surface inspections. That is what we spoke about mostly. We can also do OCR inspections. So this is optical character verification. This is an AI-based OCR approach. So with traditional OCR systems, in case you have a different font, or in case your system is not able to detect your font, the OCR might fail. In our approach, you can train inspection. So this is optical character verification. This is an AI-based OCR approach. So with traditional OCR systems, someone. Okay, I'm sorry for that. Okay, so in our OCR approach, you capture images and you train an AI model to learn different OCR, your OCR fonts. So your accuracy is increased because of that. So any kind of dot matrix OCR, different print OCR, different language OCR, we can do that. We can also do thermal inspection. This is for heat sealing use cases, where instead of using a vision-based approach, we used a thermal camera. The software approach is still the same. It's just the hardware that is different. We can also use the supervised model to do applications like object counting. So this is also an AI-based supervised approach where we train the models to detect different objects, and our models can detect those objects and give you counts, etc., etc. Now, something that is very different about SwitchOn is we also have a product called DeepInspect Cloud. This is an add-on product that sits on top of your traditional vision system. This product is an opt-in product. So in case our customers want cloud connectivity, they can choose to opt in for this product. What this enables them to do is back up all their data on cloud. So you can practically store all defect images for up to 5 years on the cloud, um, or 1 year if you choose to. You can also view quality reports from anywhere in the world practically, or in your plant. You don't have to go to your vision system, connect to the vision system and download reports. You can directly do them via our cloud portal. And you can also integrate this entire system with your ERP, MES system, SAP, etc., because we provide a REST API interface, which means any kind of quality reports can directly be piped into your MES and ERP systems. We also provide that. So a lot of traditional vision systems do not have this capability. So this is something that differentiates us. Okay, I think I'll give it back to Shashir, who will talk more about glass bottle inspection.
Yes,
Thank
sir.
you.
Thank you, Neil, for having such a.
You.
Yeah, sorry, I think yeah, so thank you, Neil, for providing us a deeper dive in how the AI-based quality inspection system is working. So just to wrap it up, actually, I'll just showcase one of the examples uh, which we have solved. So this is actually the complete EBI, that is the empty bottle inspection that we are doing for Diageo, where we are inspecting the complete 360 degree of the bottle. And this is actually inspecting the top, the crown, the bore, the front of the bottle. You can see on the right side all the different areas in which we are doing the inspection, and at the bottom, uh, because we have signed an NDA with the Diageo team, hence we are not going to share the exact video of the deployment. But definitely, if any of you have any concern related to the deployment, then you can just reach out to any of us in the SwitchOn team. We'll be very happy to share or provide the information, and probably we can also give you a demonstration at your site as well. So just to make a very clear understanding why brands like Diageo are selecting us over some of the European empty bottle inspection system, is because first and foremost is the ability to detect the defect at a very high accuracy of close to 99.5, which not even a system like Crohn's Hooft is able to guarantee. And we have not only guaranteed it, we have also demonstrated it with the work which we have done at multiple sites. The second thing is actually the dedicated support team which we have developed throughout India, and we have a multi-language support team. It's not only a single language or a bilanguage support team that we have, because we know our customers are operating at various different geographies, which can be in the west, like Bhuj or Gandhidham, which is like the complete west of India, and geographies like Assam, Duduma, which are like the complete east of India, which are like completely two different regions, two different languages. So we have developed our team in such a way that we are able to not only cater to only Indian requirement, but we have also expanded our team across the world, so that we can support the requirement of our customers across the globe. So we have three offices in India, where our headquarters is in Bangalore, and then we have a office for sales and support in Pune, and then we have an office in Gurgaon for the northern region as a sales and support, and we have a complete team who is there to take care of both sales and support requirements. And not only these, but we have a support team and our support partners as a channel partner in different geographies of India as well, who are catering or who are helping us in meeting the requirements of our customer through 24/7 time zone. And I mean, in just to let you know, except India, we have offices in Europe and in US, where we are scaling up or doubling down our expansion at multiple sites. And we have done deployment across Europe, uh, in multiple countries, even in Latin America, in Brazil, and we have also done our expansion in Japan as well. Soon, also Thailand is also one of the geography where we are expanding, and we are planning to open our office soon in the APAC region, yeah, like at the end of this year. So yeah, I think that's more from our side and what we wanted to cover